Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in the paper on optics, and we have almost come to the end of the lecture series. We saw the phenomenon of diffraction in the lectures that we have seen, and we have now the section on optics, and the contents of the lectures on holography will include photography, holography, hologram, difference between photography and holography, significance of hologram, principles of holography, recording and reproduction, and applications of holography. This will not be completed in one lecture, but we will have a part of it in this lecture. What is photography? All of you know photography contains information about the square of the amplitude or the intensity of the light that is produced by the image. The information about the phase of the wave is not recorded and is lost. This is the important point. The information about the phase of the wave is not recorded. This is the photography, wherein you find that you make use of a lens, right. The important point is in the case of photography, you make use of a lens and you get an inverted image. You got a tree here, you get the inverted image, and the nature of the image, all of you know, is a 2-dimensional image. Okay. You can see the image from here or this side or left side from right side. The image will appear to be the same. It is essentially a 2-dimensional picture, whereas a hologram is a 3-dimensional image. When you move from one end to the other end, you can see the different areas of the, or in other words, a 3-dimensional view of the object which is caught. While standard photography records color and intensity information, a hologram encodes phase and intensity. A holographic image is created using coherent light source to create an interference pattern on a film or plate. Now, what are the things that you understand? The point is, a holographic image is created using a coherent light source. What do you mean by coherent light source? You have number of light sources here. Are they coherent sources? We have seen in the Fresnel's biprism experiment, we produced 2 coherent sources, and using the 2 coherent sources, you obtain the phenomenon of interference or the interference bands and so on. So, the 2 points that I would like to emphasize at this point is, for taking a hologram or making a hologram, you require a coherent light source. That is the important point. What is a coherent light source? You make use of a laser beam, that is a coherent light source, and the phenomenon that you come across here to obtain the holographic pattern or the hologram is the phenomenon of interference. Okay. When reconstructed, the observer can view a virtual image beyond the film that contains all possible perspectives of the object that are available according to the placement of the film. This is a 3-dimensional image. You saw earlier a 2-dimensional image, the inverted image of a tree. This is a 3-dimensional image. What do you mean by 3-dimensional image? You see the depth perception. You see the along the xy plane, and in addition to that you see the depth along the z direction also. You see the the cat and other things, zebra. You see the 3-dimensional pattern. So, the 3-dimensional image, this is the hologram. So, the area of holography assumes significance because it has pervaded already in all important disciplines, in all fields. What is holography? The word holography is formed by combining the 2 parts or the 2 Greek words holos meaning whole and graphene meaning to write the image of the object fully. Thus, holography means writing the complete image, of the object. Holography is a technique which enables 3-dimensional images, they are the holograms, to be made. The important point is, as I told you, it involves the use of a laser, that is a coherent source. I told you in the earlier lecture, in the earlier slides, we need a coherent source, that is a laser. Then the phenomenon that you come across, or the phenomena or interference, diffraction, and again light intensity recording and suitable illumination of the recording. These are the things which are required to obtain holography. Now, why do you need holograms? Now, as I told you, holography has got very many applications. One of the important applications is you can distinguish or find out which currency is the genuine currency, which one is the fake currency. When you have counterfeit currency, the $100, now this is a fake currency. You see the 100, you have 0 here, 0 here, and these zeros are with greater intensity. You can find the distinction by looking at the $100 notes, which one is genuine and which one is counterfeit. You may ask whether the genuine kind of thing, can it not be reproduced or can it not be made by the people who make fake notes. This process is the master hologram that is being made initially. It is a very costly process, and so generally it is this prevents the people who to make fake notes, especially the denominations $100 and higher currencies, irrespective of the country which is making maybe 1000 rupee notes and all. They should be having this kind of holographic pattern should be there. So, holography is able to find the difference between the fake and the genuine currency. This is one example. Apart from that, there are very many applications in defense, in medicine and communication, computers and many other areas. So, the image changes as the position and orientation of viewing system changes, and in exactly the same way as if the object were still present, thus making the image appear 3-dimensional. As I told you earlier, the 3-dimensional image can be seen from a person can move from left to right. As he moves, as I will be showing the pictures to come, you can see the 3-dimensional, the various angles, you can see the person or the object. In 1948, Dennis Gaber outlined a 2-step lens-less. As I told you, in the case of photography, you make use of lens. Here, you do not make use of any lens here, lens-less imaging process. This is conceived in 1948 by Dennis Gaber, who was given the Nobel Prize in the later years. It is radically a new technique of photographing the object. It is known as wavefront reconstruction. The technique is also called holography. Actually, Dennis Gaber was trying to improve the working of the electron microscope. During this process, he came across this lensless imaging process, but he could not make a hologram because of the simple reason that he did not have a coherent light source at this point of time. In 48, there is no coherent source. I told you earlier, by coherent source what I mean is you should have a laser. Laser was invented much later, therefore, Gaber could not actually construct a hologram. Ultimately, he got the Nobel Prize in 1971 after some other people showed that indeed a hologram can be constructed because lasers were available by that time. Holography is actually a recording of interference pattern formed between two beams. You will have two beams, right, of coherent light coming from the same source. I will show in the pictures to come. You will have two beams coming from a single laser source, and they will interfere with each other. One beam will be coming straight, whereas the other beam will be incident on the object and gets scattered. The scattered light and the reference beam which is coming directly, these two beams will interfere, and the interference that is taking place is recorded as a holographic image or hologram. In this process, both the amplitude and phase components of light wave are recorded on a light sensitive medium such as a photographic plate. Similar to a photographic plate, you got a film. Here also you will be having a film made up of different emulsions, and in this film image will be recorded. So, the recording is known as a hologram. Holography requires an intense coherent light source. Laser was not available, as I told you, when Gaber formulated the idea of holography. So, at the time Gaber initially formulated the idea of holography, laser was not available, therefore, he could not make a hologram. So, we now will spend a few minutes time about different types of light. This is ordinary light, this is not a laser, whereas a laser is one which is highly monochromatic, phase coherent, and so on. You know about laser, light amplification by simulation emission of radiation, and you know who is the father of laser. Einstein is the father of laser. So, Einstein predicted laser. Laser was invented much later. The prediction was made much earlier by Einstein. So, you have white light, it contains different wavelengths traveling in different directions with different phases. Laser light is a monochromatic light having a single wavelength, and the waves are in phase, and this is a ordinary light. The white light, it consists of different colors, different wavelengths. There is phase difference or there is no phase coherence, whereas the laser light is a coherent source. Okay, what do you mean by coherence? You all know by now, because having discussed so much about the coherent sources in the case of Fresnel biprism, I need not repeat what is meant by coherent sources. The difference between photography and holography: photography shows only a two-dimensional picture, whereas in holography you can have the depth profile, and in the formation of or the production of holograms you need a coherent source of light. You all know by now what do you mean by coherence. That is, you should have a light having a single wavelength. You see here you have got light here, this has got a single wavelength, this has got a particular color, then you got a different from some other source, you got a beam of light having a particular color, that means a different wavelength. This the wavelength of this and the wavelength of this, they are different, and you can have all kinds of colors. You can make use of helium neon laser, the red laser, or you can have a green laser or ruby laser or YAG laser, yttrium aluminum garnet. Several laser materials can be used, and depending upon the energy levels, the colors of the lights which are emitted will be different. The important point is the wavelength will be unique, monochromatic, and the light waves will be having no phase difference. So, phase it is a coherent source. Okay. So, the beam will be very intense, whereas this beam will be weak, whereas this is a very intense beam. Laser beams can even penetrate the walls or penetrate the even iron or anything. One should carefully treat the laser. You got milliwatt laser, kilowatt laser, very high power lasers. Okay. So, holographic technique became a practical proposition only after the invention of lasers. This is a very important point. So, even though Geber thought of holograms when he was working on electron microscopy, and the holography could not be realized because of the fact that lasers or coherent sources were not available at that point of time. Only in 1960 and later the lasers came into existence. In this area of holography, the other names which are to be remembered are the people who contributed to the development of holography are Leith and Upatensky. They prepared laser holograms for the first time. So, the holography versus photography, when we are talking about, the credit goes to Leith and Upatensky. They are the people who were responsible for the present day holograph. Holography may be better understood via an examination of its differences from ordinary photography. A hologram represents a recording of information regarding the light that came from the original scene as scattered in a range of directions rather than from only one direction as in a photograph. This allows the scene to be viewed from a range of different angles as if it were still present. A photograph can be recorded using normal light sources. You can have sunlight or electric lighting, whereas a laser is required to record a hologram. So, to record a hologram, a laser light is needed, whereas photography you can make use of sunlight or some other light. So, as I told you, holography versus photography, it is a 2D picture, a photograph. A holography, you can have a depth profile, and also not only that, when you move along, when you go from left to right of the hologram, you can see the different areas. Not only that, it is worthwhile to mention at this point of time, different pictures can be recorded on the same holographic plate. You can have a film on the same holographic film, different pictures. That means, when you see from left, you will have a building will be seen. From the right, when you see an animal will be seen. Therefore, different images can be put into a hologram. So, these images can be seen when you move the angle, when you see the image from left and when you see from right, the different images can be seen. So, the images can be made to overlap with each other. Here the same rat is there. So, it is viewed from different angles. Two photographs of a single hologram taken from different viewpoints. In this picture, you see again the 3D image display. You see a person here, you walk along in this direction from left to right. The image that you obtain looks like this. So, the different image perspectives at different angles. So, you take a photograph ordinary photograph, you see the image from left or right or straight, the image will appear to be same. But in a hologram, as I told you, the image will be different, the three-dimensional profile can be seen. Not only that, the most important thing is different pictures can be recorded in the same hologram, or as I told you, you can have a building and you can have a temple, and so these, from you look from left side, you will see the building, from the right you may see the temple or some other mandir or whatever be the thing. So, it is possible to have more than one image in a hologram. Unlike a photograph, a lens is required in the photography, as I told you, whereas in holography you have you do not require any lens. A holographic recording requires a second light beam, the reference beam, to be directed onto the recording medium. Okay. You got the reference beam which goes straight, as I will show in the picture, whereas the other image, other beam will fall on the object to be seen, whose image is to be obtained by the phenomenon of what? What is phenomenon? The interference phenomenon. The two light beams will be interfering with each other. A photograph can be viewed in a wide range of lighting conditions, whereas holograms can be viewed only with very specific forms of illumination. This is a very important point. You see a hologram, again you need a laser. You cannot see the hologram by normal means. When a photograph is cut in half, each piece shows half of the image of the scene. When a hologram is cut in half, the whole scene can be still be seen in each piece. This is an important point. If you cut a hologram, again you can see the images, right, the whatever image that you are seeing, the images can be seen even when you cut the hologram. This is something like what I will say is it can be thought of as if you are viewing a street outside a house through 4 feet by 4 feet window, a big window, right. You see the left and right outside what is happening in the street. Then through a 2 by 2 feet window, the thing is the window is cut into half the size, then you see through the window once again what is happening outside. Therefore, when you cut the hologram, again you see the image, right. This is because whereas each point in a photograph only represents light scattered from single point in the scene, each point in the holographic recording includes the information about light scattered from every point in the scene. Therefore, you can cut the holographic plate or the hologram, still you see the image, the two images, the whatever that information that you get will be seen. One can see all the same things through the smaller window by moving the head to change the viewing angle, but the viewer can see more at once through a 4 feet window. Through a 4 feet window, you got a wider perspective of what you try to see, rather than 2 feet or 2 feet by 2 feet or 1 foot by 1 foot. Okay. A photograph is a two-dimensional representation, as all of you know. The reproduced viewing range of a hologram adds many more depth perception that were present in the original scene. The cues are recognized by the human brain and translated into the same perception of a three-dimensional image as when the original scene might have been viewed. A photograph clearly maps out the light field on the original scene. The developed holograms surface consists of very fine, seemingly random pattern which appears to bear no relationship to the scene it recorded. Unlike the conventional photography, lens is not required, as I told you earlier. A hologram is a resultant of the interference between the two waves, as I told you earlier. Now, what are the two waves? Now, you see a coherent source of light, that is a laser beam is coming. You have got a beam splitter. We have come across beam splitter, semi-silvered glass plates and so on in optics so far. So, a beam splitter, it splits the beam into two halves. One is reflected, the other is transmitted. This transmitted beam, you have got an arrow here, it falls on the object. The object is the one whose image is to be obtained. So, the light is scattered, it comes in this direction, whereas the light coming from this beam splitter in this direction, right, then you got a mirror here, it makes the light beam to come here, it is falling on the photographic plate. So, this is a reference beam. Why it is called a reference beam? It does not fall on the object, whereas this beam, illumination beam, is the one that illuminates the object. The scattered beam is coming here, or the reflected beam is coming here, whereas this is the direct beam, the reference beam, because it is simply split up by the beam splitter. It comes here, falls on a mirror, it does not interfere with the object. It is a reference beam, whereas this is a illuminated beam, right. This is the beam that light falls on the object. Now, this will be explained once again by this picture. This is a better picture in the sense the concept is brought out clearly in this picture. So, an object beam, which is the light scattered off the object and a coherent background, the reference beam, which is the light reaching the photographic plate directly, as I told you. You see here, this is the laser beam, the object beam here, lens here. You see the mirror reflects light and it falls on the object. This is the important point. So, the light beam that is coming from the beam splitter, it comes in this direction, falls on a mirror here, and falls on the object, and then from the object it is scattered or reflected in this direction. On the other hand, you got a reference beam coming here, you got a mirror here, and then you got a lens, and then it comes in this direction. You see the beam is coming here, right. You see the stripes, the beam is coming here, this beam is coming here, two beams are coming. One is from the object, light reflected by the object, the other is the reference beam. What will happen? These two beams obviously will interfere, right. So, the phenomenon of interference is very important. So, the two beams interfere, and whatever you get as the output of the interference will fall on the plate holder, will be received on the plate holder, and that is important. This picture is of paramount importance because it brings out the concept behind the holography or the principle of holography. It involves the two beams. One is the reference beam, which is nothing to do with the object. The other beam is the beam that is incident on the object. It is getting reflected or scattered, and then the two beams interfere, giving rise to the hologram. So, this is the principle of holography. As I told you, the holography is due to Leith and Uppendix after the invention of the laser. Let me now summarize the lecture which was given today. A photograph gives a two-dimensional image, whereas a hologram gives a three-dimensional image. Camera requires a lens, unlike the hologram. 3D image can be seen from all angles obtained in holograms. The phenomenon of interference is used to obtain holograms. We will go to the question session. The questions are: what is holography? What is the difference between photography and holography? What is the significance of holograms? Explain the principle of holography. With this, we come to the first part of the lecture on holography. The rest of it we will see in the time to come. Thank you.